Hello, the internet, and welcome to Open Source Directions, hosted by Quansight, the webinar that brings you all of the news about your favorite open source projects. My name is Anthony Skopatz, your host for Open Source Directions.
Hi, I'm David Charbonneau, and I'm excited to be co-host for this episode of Open Source Directions. I lead the development of open teams here at Quansight, and I'm based in Raleigh-Durham, North Carolina.
I'm Holden, and I work on a variety of open source projects at Google, with most of my focus being on Apache Spark. My preferred pronouns are she or her, and as an author, I am required to ask you to buy several copies of my books with your corporate credit card.
just a whole stack.
Yeah,
just completely.
Minimum.
Right.
It's fine.
Yeah. Well, we're really excited to have you here, Holden, and thanks for joining us today and talking about PySpark. But before we get into our discussion of PySpark, we're first going to do our famous Tweet of the Week section, where each of our panelists presents a tweet that they've been enjoying this past week. Holden, you are up first.
Oh dear. So I got like a tech one and a non-tech one. The tech one, which I'm really most excited about, and I'll just do that one, is there's this wonderful tweet about attention people still obsessing over Python versus RStat wars. Wes McKinney is speaking at this week's RStudio conference, and it just goes on to talk about how the war between these two things is just quite silly, right? We don't need to fight with each other just because we prefer different programming languages, and the tools are actually now becoming available that we can work together without having to write piles of special glue code, and I'm really excited about that.
Yeah, it's true. It's great. David, do you have a tweet to share with us?
Yeah, there was an interesting tweet from Adrian Collier, who he writes a blog called The Morning Paper, and if you haven't looked at that, I highly recommend it. But this week he tweeted about SageDB. They had done an experiment where they applied machine learning to data generated about query patterns and things like that in order to generate the indexing and query plans for query execution. And they sped up some significantly complicated join queries like 300 times by customizing the indexing and the query planning. So very, very interesting development in terms of where the future of databases might go.
Very cool. Thanks, David. For my part, eTadao tweets, "Congratulations for the successful compiler migration, Condaforge. More than 3,300 packages. It's not an easy task. You have an awesome team and infrastructure. P.S. With the switchover in our company, was seamless. All Linux jobs are still passing now with a lot of GCC 7 packages." So thanks for the kudos, eTadao. Really appreciate that. At this point, we're going to go ahead and dive into a brief introduction of PySpark and what the project is. So PySpark is the Spark Python API, and it exposes the Spark programming model to Python. And we just have a couple of questions that we're going to ask Holden here and get some answers back. So,
first question, why was this project started and what need does it fill?
So it's a great question. PySpark was started essentially because there were not good big data tools in Python at the time. And it's to provide distributed big data tools to Python users. And it's grown since then to allow Python users to access JVM libraries and actually vice versa, have the Python code accessible from the JVM libraries, which is really useful when you have a data science, data engineering organization sort of combined, and they maybe aren't used to speaking sort of the same language. And the TLDR is, if you're in the situation where Pandas isn't working on your MacBook anymore, you could use Spark. Probably just rent a bigger computer. But when you start running into the point where you can't rent a bigger computer, that's when you start using Spark.
are there any alternative projects out there?
Yeah, there's a lot. Dask is a really cool pure Python alternative, which I think is really great for shops which don't have a mixed language environment.
Yeah.
Or specifically also shops that don't really have existing Hadoop installations or existing clusters or things like that. Because Dask is amazing, but one of the challenges is it doesn't integrate nicely into this existing very JVM heavy sort of environment. And so it can be challenging to get your data into Dask if you're in a very JVM sort of centric world. Unfortunately, though that may be. You could also use Hadoop streaming if you really, if you're like paid by the hour.
Yeah, that phrase scares me, I'll admit.
Yeah. In this case, streaming does not actually mean streaming. It just means that the data is put over a Unix pipe.
Yeah, makes sense.
Yeah, it's great.
So what is PySpark built on?
Yeah, so if you look at the architecture for PySpark, you will go crazy. And so it's best not to think about it while you're using it. So I want to be clear. I'll tell you how it's built, but if you have to use this, something has gone wrong. So the first thing is PySpark is built on top of Spark, which is built in Scala. And notably, Scala runs in the JVM. And so we use this thing called Py4j to allow Python and Java to talk to each other. But there were some performance challenges. So we also use a combination of Unix pipes, sockets, and files to copy data back and forth. And we do really intelligent choices relatively about those things. So it's just like this ridiculous Rube Goldberg machine, which somehow works. And so Spark is part of the Hadoop ecosystem. You don't need a Hadoop installation to use it. You can just use it straight up on a vanilla cloud provider or raw VMs. But one of the useful things about it is that if you do have a Hadoop installation, it can speak to all of those file formats and you can just use it really easily. And there's some exciting things coming in the future. Actually, they're here now. Apache Aero is being used to make this integration less terrifying. Still not reasonable, but less terrifying. And I'm really excited to see how that's going to progress in the future. Right now, it's only used in very sort of narrow use cases because they're the ones where we could guarantee it was going to be correct. But I think as time goes on, we can start to use Apache Aero in more and more use cases.
Sure. Yeah, that sounds great. So who started the PySpark project?
So,
or is that
Spark was a
yeah?
Oh, sorry. Yeah, it's like a complicated question, I guess. And occasionally people have gotten in trouble for saying that they started Spark because of branding concerns. Essentially, when a project is donated to the Apache Software Foundation, things that I don't understand happen. And so what became Apache Spark started out of UC Berkeley by Matei and a lot of other people at the AMP Lab, which is now the RISE Lab, unless I got those in reverse. Regardless, really, lots of really smart people at UC Berkeley were the initial creators of it. Many of them now work at the company called Databricks. I used to work there. I do not. I like money. And I'll leave it at that.
Okay. Yeah. And hence Google.
Yeah.
Well, who maintains the project today?
That's a really good question. And I think it's a thing that we often overlook when we think about open source. And so the nice thing about Apache projects are that it's not just one company, right? It's not like if Databricks stops existing, we're all screwed, right? Which would be unfortunate because my career is Spark, for better or worse. So it's folks from across the industry. So you've got people from Cloudera and Hortonworks, although I guess those are the same now. But you've got people from all kinds of different places. I'm one of the maintainers. I work at Google. There's some of the maintainers work at shops that use Spark in addition to vendors. Cody is one of them based out of Austin. On the Python side, it's a lot smaller, right? So Spark is a really large project. And the Python specific component is you have to find people that know both Java, Scala, and Python and aren't afraid to mix the three of them together, right? And so that's like No one.
Yeah.
But if you give them money, that's a list of 4 people, which is Davies. I don't actually know how to say Hyokwan's name very well, but he's really awesome. I think he's based in Singapore. Brian Cutler and we used to work together at IBM, and myself. And people from other parts of the project help out with the Python side, but we're the 4 who really hang out and try and make the Python integration rocking,
Right.
For the most part.
Yeah, that's amazing. It's quite the it's a non-standard language combination for sure.
Yeah. Oh yeah,
So-
and if you want to see the full list, you could go to bit.ly/spark committers in camel case, and there's like there's a lot of committers.
Sure. Yeah.
67 in total.
Gotcha.
But
Yeah. There's a long
It's all-
tail, right?
4. Yeah.
Cool. So what communities are the users and contributors typically from? Are they more from the Java, JVM, Spark side, or are they more from the Python side?
Yeah. Largely from the JVM side.
I see.
So there are contributors from the Python side, and one of the things that I worked on was like the pip installation stuff, and there we had lots of people from the Python side because like Java people are not a package fucking damn it. Okay, pretend that didn't happen. Anyways, Java people don't know how to package like Python projects in standard ways, right?
Right.
And so really nicely, like the people from some of the Netflix people came in and helped us out with that. Very from the Python community there. But it's definitely largely JVM people who have kind of learned some Python, and the API feels like that.
Mm-hmm.
You're like, oh, camel case, interesting choice. Right.
I was going to ask, is the project participating in any diversity and inclusion efforts?
Yeah, no.
No.
The short answer is no. Long answer is some of the individual committers or PMC members do stuff.
Mm-hmm.
I would really like it if there were other people who perhaps did not go to UC Berkeley hanging out on the project with me. And I don't just mean like, let's get some white guys from MIT.
Right.
Although, anyways, there's individual stuff, but there's no like overall diversity projects that the project has undertaken.
Mm-hmm.
I try and do live code reviews, and I also try and coach people one-on-one. If you're from an under-indexed community and interested in contributing to Spark, I'll try and talk you out of it for the first like 5 minutes. But then if you're still like, no, that sounds like a good idea, I would love to work with you. And I really be cool. And like we've done some of the like generic corporate like diversity-ish looking stuff. We got a little rainbow logo for Pride Month, you know, which to me like meant a lot because it's like the project that I've worked on
Right.
for 5 years. I'm queer, but and I hadn't seen that happen with other open source projects all that much, but we didn't do anything besides make a rainbow logo. We didn't follow that through with anything else.
Yeah. With anything more formal or anything, but
Yeah.
the one-on-one interactions are very important too. Right?
Yeah.
So
And I feel like if we just keep asking the question, eventually the answer is going to change.
yeah.
Yeah,
Like-
there totally are projects that do, right? Like
Yeah, there are.
Yeah.
and I'm really that's part of why I would try and talk people out of working on Spark, is I'd be like, there's these other projects which are going to be so much more welcoming. But if Spark is where you're happy, like I would love to help one-on-one too, right?
Right. At this point, we'll go ahead and dive into a PySpark demo.
Oh dear.
Yeah, so there were some technical difficulties right before the call here, but hopefully Holden can rally here and show us some PySpark, some cool PySpark stuff, so that we have.
Okay.
Are we good to go?
We will find out.
Yeah, that's how I like it.
Okay, cool. So, so I'm going to start. So this is big data, and big data is, of course, the same thing as word count. If you've read any introduction book to big data, it's definitely focused on word count, and this is going to be no different. And I'm going to show my original plan of what I wanted to show didn't work out, but this is fun too because it's word count. And it's not just word count, it's word count on top of Kubernetes. So it's the future. So interestingly, Spark, Spark can totally run inside of the Hadoop ecosystem, but it can also run on top of other cluster managers like Mesos or Kubernetes. And it's in the third cell that we get to our first bug in Spark in the word count demo, which is surprising. But okay, so this is importing the PySpark library. We have this conf object, which just has a bunch of settings here. In this case, this is just saying like, this is my Kubernetes master, and I just have a proxy going to, which is why this is a local host IP. And the deploy mode being in client, you can sort of run your apps so that you've got like a client interface like this, or you can run it in sort of a headless mode, where instead of having your Jupyter notebook on your local machine, you like submit your Python files to the cluster, and you wouldn't like have to keep your like client up and running to run. It would just run and finish, and everything would be in the cluster. But because it's a demo, it's nicer if you can see it as we're going, so we'll use client mode. And this is the container image here, and this is just because I'm going to use Google Cloud Storage, and that's not built-in support, and so I just use a container which has the dependencies I need built into that. I set the Python version here, which we promptly ignore later. Oops. We'll fix that in the next release. So I configure the Python version, which is ignored, set a namespace, and I ask for 2 executors. We can replace this with another number, but I restarted the cluster 5 minutes ago, so let's not overdo it. Well, like we could ask for 2,000. We could ask for 1. And another interesting point about Spark is if I completely screwed up my cluster, or if I was like working locally, I could just set this master here to just be local. And that would just work, right? Like, and it would just give me a local emulation.
Very cool. Yeah.
That being said, we have a cluster. We might as well use it, right? So, okay, conf. I set this environment variable, which I shouldn't need to set, but I do. And then I get a Spark context. And then I have this collection of diversity data, and this is just like loading some data in from a cloud storage object. And one of the things about Spark is that it's lazily evaluated. And what that means is this file here, we just ran this cell, but Spark has really done nothing. So if I go ahead and insert a cell below this, and I like go IDK, I like coffee, and I misspelled coffee, right? And then I run this, it should fail. It fails, but notably, it didn't fail here, right? It only failed when we tried to trigger the action. And this seems kind of esoteric and weird, and like it's just going to make your programs impossible to debug. And those are all true. But it also means that there's this thing in big data where, it's often more expensive to just read over your data multiple times than doing your computation. And so for people who are coming from a Hadoop background, you spend a lot of time figuring out how to do stuff in the minimum number of passes over your data. But by doing this all lazily, Spark will just like take everything and collapse it down. It builds a graph of your computation and then minimizes it for you later. And so you don't have to like concern yourself with this normal problem. So we'll just comment that out, go back, load some real data, count it. Yay, it works. Okay. And then we're going to tokenize it with my world-class space tokenization, which I can get away with using because I live in North America. And words, and then collect. Yay! And we can see that, so this is a shell script, and it's got Jupyter.org in it, Google, Dataproc. Comment is pretty common too. Okay, all pretty basic things, right? And this is really cool, right? Like this ran on a cluster. If we go look here, no, not there, not there. Okay, here. We can see we've got these two executors. If we go into jobs, I can go click on this job, and yeah, let's go look at this reduce by key, and we can get this like visualization of the computation. And this is pretty basic, right? We loaded some data in, we did a reduce by key. You know, we didn't do anything too complicated. We didn't join any tables, but you know, we can see that it ran on the cluster. We can see, you know, which executors ran what, and if stuff failed, this would be a good place to try and figure out what had gone wrong.
Right. Just as a quick question, what are some of the optimizations or graph reductions that get applied before execution? Just
Totally.
yeah.
Thank you for asking that question. So the simplest one is when you just have two things happening right after each other. So if I have a map and a map, right, we'll just fuse those together if we can.
I see.
Right. There's other cases though where we do really cool stuff that I really like. We have two different APIs, and let me actually bring up something in the second API and show it to you, and we can talk about that one.
Okay.
Really quickly. Whoa, sorry, there's a shit ton of code here. Okay, so here's this second API. Let me zoom in a little bit. And so we can see here, there's like this data, and we can see what I've got this like select statement here, right? And ignore the exception, the line above, I assure you everything is fine. And this is really cool because one of the things that will happen is when you're using this newer API, which is called the data frame API, to give people false hope, is it looks at the select statement, and if your data is like represented in such a way that it can only read that subset, it will push that filter down. And that's really amazing to me, right? Like we do a filter push down from your Python code to your storage engine. And
that's neat. Yeah, that's really neat.
Works often enough that I can say that, provided no one knows where I live. Right, and so like we have this much longer schema, and then I say like this is the only part I care about, and given that this is probably stored in Parquet, we will just read only those fields, right? And that's really efficient. There's other things which are really cool with joins, where if you've got like sort of a complex graph, it'll do some smart things there.
Sure.
There's places where it does really badly. If you're trying to write an iterative graph algorithm, it doesn't do very well. There is a graphing library inside of Spark. Spark has a whole bunch of different components. It has machine learning, it has graphing. It pretty much, if it was a buzzword at the time Spark was made, they were like, ooh, let's throw in a bit of that and see if we can raise some venture capital money. And the answer was yes. So there's graphing and machine learning. And if you want to do graphing, the engine isn't well suited to it, but you can look at the graph library to see the like hacks that are done to make it all work.
But it exists to provide some minimal functionality in that space. Yeah.
Yeah,
very cool.
It works actually pretty well. It's just really disgusting when you like look under the hood.
Yeah. That's why I probably won't be looking under the hood anytime soon.
Not encourage that.
Yeah. David, did you have any questions or anything you wanted to ask?
No, it looks really, really cool. I haven't tried it before. I did explore Spark back when I was doing more Java coding. So it's cool to see the intersection of Spark and Python.
Yeah, excellent. Is there anything else you want to show off, Holden, in the next minute or so of our demo?
Well, just really quickly, this UDF right here is, so UDF means user-defined function in Sparkland. And so this thing which says pandas UDF is actually an Aero UDF. And so what that means is this is the new way of sort of registering a custom piece of Python logic to run in Spark and have Aero used as the interchange format. And what's really nice is like, yeah, this part here doesn't look like what you're used to seeing, but your code here, this looks pretty normal, right? You're passing a pandas data frame, and you just get to have a party, and then you get to use all of the wonderful Aero accelerations. And so I think this is really cool. We don't have enough time to actually run this UDF, but like, this is pretty cool. And if you want to go play with it, it's all in my GitHub in a project called Diversity-Analytics.
Excellent. And just as like a very, very quick follow-on question to that was, do you have to do those UDFs? They don't get the global context. It seems like and you have to import everything in the function, or do they get the kind of full scoping that a normal Python function would?
So this is sort of quasi-related.
Okay.
So you totally can. You can implicitly reference these things. However, what will happen is Spark will pick those up and serialize those for you.
I see.
It might not be what you want.
Right.
In fact, pretty often it is not what you want.
Sure.
And so we just define it locally here.
Gotcha.
Normally you'd use a class and you'd have nicer organization, but this is just in a notebook for a quick demo.
Yeah. Okay. Cool. Thanks for answering that question. At this point, we're going to move on to our roadmap discussion. And so this is sort of the meat of the episode where we'll talk about where PySpark is going and sort of what's on the wish list for the future of PySpark and maybe Spark kind of more broadly. And so we've got a few items here to chat about. David, do you want to go ahead and ask the first question?
Sure. One of the things that we noted was you're looking to do better multi-language support. Can you give a little more detail there?
Sure. Let me just turn off my screen sharing really quickly.
Oh, sure.
Okay, cool. There we go. So I think this is a thing that I'm really excited about. Multi-language support is really important for a lot of enterprise customers. And enterprise customers are the reason I have a job. And I can pay rent on this place in San Francisco. But also Apache Aero is really exciting to me too, right? And it's really nice to have this ability to use libraries from each other, right? If I'm a Scala developer, I don't want to have to try and make NLP libraries every day, right? I want to just have fun writing my functional code, pretending that I'm writing Haskell or whatever it is in my life. I want to focus on what brings me joy. But on the other hand, no one else was really like, you know what I want to do is recreate Spacey in the JVM, right? Like, porting code really sucks. If that's your job, I'm sorry. I hope you get paid well. So the idea that I won't have to spend a lot of time porting my examples around or porting my code between these different systems is really important. And this is all really powered by Apache Aero, just giving us a format that we can all understand and talk to each other with. Right now, we use it. We don't use shared memory buffers yet. We use the Aero format between the different languages. We still send it over either pipes or files, or possibly shared files, but not yet shared memory buffers. And I think if we can get to the point where the shared memory buffer stuff isn't just a pile of seg faults, like we'll see real useful multi-language pipelines, even in the cases where like rewriting it isn't to the scope of rewriting Spacey. It's just like, well, I mean, my coworker wrote this function. I just want to use it. I don't have the like hour to understand what's going on. And that's really my goal for what's going to happen here. Brian Cutler at IBM is working on this a lot. Some of the people from NVIDIA, I think, are also involved, and Ursula Labs are working on this too. Really, really great stuff. And I know there's people from all kinds of other places too working on that. And it's not just for languages which you think of as sort of traditional Spark languages, right? Like Python, R, and Scala. There's also things like CUDA, right? Which can also understand Aero format. And so if we start to make it easier to integrate like CUDA accelerations into your pipelines, that's really cool. And as someone who works at a cloud provider, we can sell you a lot of GPUs. And that's a really exciting sort of like thing to be able to go and tell my boss.
Right.
And I value making my boss like at least excited 2 or 3 times a year, which is also how often we have performance reviews.
So I imagine JavaScript is kind of up in that list too for the multi-language support stuff, right?
So JavaScript is actually a really fun special case. It's so cool. Sorry.
Yeah.
Can I take us off into the weeds for JavaScript?
Yeah. Go ahead. Go ahead.
Okay, cool.
Yeah.
So okay, how many are you two familiar with Jython?
Yeah.
Yeah.
Mhm.
Okay, cool. So keep that in mind while this is all going down.
For
Okay,
those who
so-
don't know Jython who are watching, it's a Python interpreter written in Java.
Yeah, I don't remember the JSR number. I feel like it might be 233 or it might be 323 or something like this. JSR scripting languages. Which JSR is that? JSR 223. There we go. Everyone's favorite Java Standards Committee reference number, right? JSR 223. Lots of fun. And it gives us this sort of method of having dynamic languages in the JVM. It's really cool, really great. And we ship a JavaScript interpreter that way, right? That's pretty standard.
Oh, interesting. Okay.
And so this is really cool. But it turns out when you go to JavaScript developers and you're like, yo, do you want to like write some JavaScript for the JVM? They're like,
No. Yeah.
Normally they don't even say no. They just kind of like keep walking past me at the conference and they're like, I don't know who that person is. And so it's just like, that's not going to be a success. But one of the really nice things about JavaScript is that it's really easy, right?
Mhm.
And I can actually just like pick up your JavaScript lambdas from your V8 VM, shove them over the wire, and evaluate them in JSR 223 or whatever the hell it is, right? And this actually works. It's so cool. So you can have your like happy native client thing here, and you can pretend that your life is normal. Everything is fine. And then on the other side, magic will happen. And it's really cool. And there's an implementation from some folks I used to work with. Tried doing the same thing with Python, added 200 megs of dependencies.
Easily.
No one was excited.
Yeah.
And Python 2 support only. We're like, and also like the amount of special logic that I had to do to serialize the functions from a like regular Python VM into a way that the Jython VM could understand it was not a lot to support word count, but when I wanted to support things besides word count, surprisingly frustrating.
Yeah.
And so anyways, whatever. So we tried it for Python and it didn't work, but it does actually work really well for JavaScript.
Huh.
So JavaScript doesn't, we totally could do it with Aero.
Right. Yeah.
We also can just avoid that entirely.
I see. Okay.
So we'll see what path JavaScript takes, and it's like a special case because it's the only language that I know of that actually really works well in that dynamic language runtime.
Huh. Yeah, that's really cool. That's fascinating.
Sorry, I get that it brings me so much joy and happiness because I think terrible things to computers.
Yeah. No, that's awesome. The next thing on the wish list that we have here is the more SQL statement. So could you discuss some of the, I suppose, terrible hacks that have to go on to make more SQL available to PySpark?
Yeah. So right now so SQL is like technically like a multi-language pipeline in that you can embed SQL in the middle and that's fine.
Sure.
And I think that's great, but like realistically, maybe not exactly a multi-language pipeline, but it's really cool. The SQL engine right now is a entertaining mix of components. So it's got a bunch of stuff from Hive, but then it has a bunch of stuff sort of to replace those different components.
Sure.
And this works, right? I want to be clear. I'm not saying that this is like, these are all sort of weird Rube Goldberg machines, which surprisingly work really well, but it would be really cool if they were more understandable and perhaps supported more standard things as well.
Sure.
And one of the things that we're missing in the Python interface specifically, and this is sort of a mixed feeling on how people feel about it, is types. How do you all feel about types?
In terms of SQL in specific, or like adding types to your specific columns, or what? Just in general?
Yeah, having typed representations of your SQL data.
Yeah.
Is that a thing you care about, or is that a thing where you're like, whatever?
I think there's most people, at least in kind of the PyData community. Not that I'm trying to speak for everyone there, but is that's totally normal and fine, right? Like that's what we do with NumPy. That's what we do with pandas. Basically every data frame. Like having typed information is beneficial in a lot of ways. So yeah. For specifically this use case.
And so we don't.
Yeah, I see.
And it's like, it's a
Yeah.
little rough, right?
Yeah.
And so I think one of the areas, and this is on the roadmap, but if I'm realistic, this is the most likely thing to drop from the roadmap because I don't know who's going to do it.
Right.
We were like, yeah, we should do this.
Right. So this, the purpose of our roadmap in many ways is to sort of say, like, here's where you're looking for contributors, here's where you're looking for funding. These are opportunities for people to get involved because, like, perhaps the current team will get to it eventually, but it could be sped up or accelerated, or it'll happen at all if there's funding that comes in to support those kinds of things, or funding, or people come in and contribute back to the project. So, yeah.
And actually, on like a little bit of a side note, if it's okay about that.
Yeah.
Like one of the areas where we feel the most pain in Spark is that we don't have enough reviewers. And this is the classic problem of like our maintainers burn out, right?
Right.
We've got like 4 people maintaining a Python interface used by I don't know how many billions of dollars of transactions.
Right.
And like, it's cool. I got a nice job, but like I have that job regardless of if I do this work or not, right? So like and it's sort of the situation that we're all in. And so what we really want more than patches, not that we don't want I don't actually want patches. I want reviewers, right? Patches are great, and if you fix a bug that I'm encountering, I will totally review your patch.
Right.
But if I could get people who understand Python to come and help review the Python code that's being contributed by really well-meaning JVM developers who are trying their hardest, I would be so grateful, because I just don't have the bandwidth for all of that.
Right.
We have like 500 open pull requests, give or take. And like, we just can't keep up. We need more reviewers. You don't have to be a committer to review an open source project pull request. You can give and help us, even if this is your first contribution to the project. Right.
So, in that sense, even it would be beneficial if a company who's using PySpark a lot and have a lot of PySpark developer or people who are developing with PySpark could contribute back some of their time just to reviewing the PRs that are open.
That would be so amazing. Yeah. I would, if you're at a company with that, and if you don't know how to get started, but you want to help, like I want to help you help us, because I am way too lazy to do this myself.
Yeah, there's the maintenance problem bites us all, I think. So, yeah.
Yeah.
Well, another item you have on the roadmap or wish list is support for more streaming.
Yeah.
Yeah.
So right now, Spark has somewhere between 3 and 4 streaming execution engines. And so clearly the solution to this is to add a 5th one that will just definitely, for sure, unify all of them for real this time.
Absolutely.
So that's what I'm looking forward to. I mean, more seriously, there's a bunch of things that really I'm looking forward to trying to see us support. We have this sort of low guarantee streaming engine where you just need stuff to be really fast, but you don't really care about your data that much. And I'd like to see us perhaps find sort of a middle ground solution to that, where you care about your data enough that you don't want us to lose it, but you would still like it to be fast. Because I'm not like there's totally use cases for like really fast but loses some data. Like if you're doing like trading, or if you're training models and you need to update them really quickly, but you've got billions of records coming in per hour anyways, so if you lose 1%, who really cares? But I'd really like us to sort of make that knob more tunable, right? Right now, you sort of get to pick between one of these 4 sets of trade-offs, but you don't really, if one of those 4 sets doesn't match your needs, we're just like, well,
Kind of out of luck.
sorry.
Yeah.
And so I'd like to see us offer something a little more flexible to users so they can configure it to match their needs. And I'd also, 2 of the engines use different APIs, and I'd really like to get rid of the old API, but to do that, we really need to get the new API to be a full superset of the old API, and we're not there yet. And that's really my goal. Is I don't necessarily want to kill the old API right away. Like, I realize that will go over poorly.
Yeah.
But I would like us to be in the point where we could kill the old API, and it's reasonable to deprecate it and tell people to move forward.
Right. There's some migration strategy there, basically.
Yeah. Right now, the migration strategy is rewrite your code, and I want a migration strategy that is like rewrite 5% of your code.
Right.
Yeah.
Yep.
So we're working on that.
Well, we have a lot of questions that have been asked by the viewers today. So is there anything else in terms of roadmaps that you want to discuss very briefly before we go on to our Q&A section?
Totally. There's a bunch of machine learning changes coming in the future around supporting deep learning. Really excited about that. It's coming in a very different sort of architectural way than our other changes historically.
Interesting.
But we'll just sidebar that and just say there's some fun stuff coming in the deep learning space, and I'm excited to see what we support there, but the details would take probably another webinar entirely.
Well, maybe we'll schedule that for the future. So yeah, it's been really great. Again, these all sound like excellent areas where people can either come in and contribute or help review or fund these particular directions for PySpark. So at this point, we're going to go ahead and answer your user or the viewer questions here. David, you want to go ahead and take the first question?
Yeah, our first question comes from Avirup Chakraborty. Can you compare how PySpark is different from Dask?
Sure. So the main difference in my mind is Dask is purely Python. It's you can accomplish pretty much the same tasks either way.
Mm-hmm.
But if you need to work inside of an existing data infrastructure system that is not pure Python, you're probably going to want to look at Spark. On the other hand, if you're in a pure Python shop, or if you don't have existing data infrastructure that you're having to integrate with, Dask gives you a lot of flexibility and a lot of power, and you don't have to deal with the JVM. And really, dealing with the JVM sucks. That's why people pay me money.
Yep. Ashish Patil asks, I have experienced in one of my codes that when I remove some simple Python code from PySpark, it runs smoothly. But along with Python, it goes for toss. I assume that means an error message. So I guess this is a question about running between running normally on Python and running in PySpark, and what happens when you have the code run correctly on Python, but it throws an error in PySpark.
Sure. So there are lots of reasons why this could happen. The most common reason why this happens is serialization problems, right? As we were talking about, what Spark will do is to allow your program to succeed, it'll just be like, well, these are all of the things that your function touched. Let's grab those and send them over the network. However, some objects get really pissed off when you try and send them over the network. So the most common problem is a serialization error. That being said, I do have this talk from Pi data somewhere. It's on YouTube on debugging Pi Spark. And if you watch that, there's a good chance that I'll talk about your error and what it means. And that's probably a good start. If you've got a corporate credit card or a Safari account, I also have a thing on Safari about debugging Spark. But yeah, debugging Spark is part of why they pay us money.
Yeah.
It's painful. Without the specific error message, I'm just guessing at serialization because that's the top error that I see. But if you want to comment with details on your error message, we could come back to the question later on. If that.
Yeah, if we have time, we can try to get back to that. We do have a lot of questions though, but yeah,
Okay,
thanks for answering that.
The next question is from Travis Oliphant. He asks, is the new RISE lab still involved with Spark, or are they just doing new things like Ray?
That's a good question. So I'm not affiliated with Berkeley. I do not have a PhD, nor did I even drop out of one. So this answer is based on my understanding and not necessarily the official position of the RISE lab. But my understanding is that they're mostly focused on building new things. Now, some of those new things are being built with Spark, but they're not building Spark anymore, right? That's not a research project anymore. Spark is a commercial thing now, right? This is not what it's not how they're going to publish papers.
Yep. Shiraj Prakash asks, is it a bad idea to save the data frame using an overwrite method if we are saving the data frame to the same file they read to create it? Yeah.
That's a bad idea. Don't do that.
Yep.
So we talked about the lazy evaluation,
Right.
Which means that Spark will not actually read the data until you go to save it out. So there's a chance that Spark will overwrite the data while it's reading it, and that will go poorly.
Yeah, sounds like a mistake in many situations, even for normal file systems. So.
Just do an atomic move afterwards.
Yep.
Robert Harding asks, what's the best way to get started learning Spark?
This is a question that I love. I have a wide variety of books that I've published, many of which will not help you. But so I'm very biased. I find that I like reading as a method of learning. So I think Learning Spark, which I'm a co-author of, is good. Learning Pi Spark by Denny Lee and Tomas. I'm not entirely sure how to say his last name, and I don't remember it, but it starts with a D. Is also a good resource. Those are two sort of good books. There's also like Spark: The Definitive Guide, which, despite being called the Definitive Guide, is more of an introductory book than I would consider. So it's totally an option too. If books aren't your thing, Paco has a really amazing video. You can find it on YouTube, or once again, if you have a corporate credit card or an O'Reilly account, there is a nicer, more polished version on Safari that you can check out. They've got like a learning pathway there that's pretty good. I like it, and I have a Safari account.
Excellent.
Yeah.
Great. Ashish Patel asks again, it would be great if you could share any ideas on real ETL capabilities like update and upsert to replicate in a similar manner in PySpark, the same as we do in expert ETL tools like Informatica and Data Stage. Do you have any comments? I guess that's really more of a
Yeah.
Is that on the roadmap or horizon at all? Or
I mean, so there's some interesting questions. So part of lazy evaluation, to make that really work, is that you need immutable data structures, right? And so if I upsert into a table, I've changed that table, right? And so now this is going to break some of Spark's computation model conceivably.
Right.
To a degree, Spark streaming gives you like, you can have like this table which represents like sort of this linear time progression, and it can sort of look kind of like that, and it's okay, but I don't foresee these things happening. They don't match Spark's execution model well. We're just about like ingest a thing and make a new thing. And if it doesn't match your need, it's okay. Spark is not supposed to solve everyone's problem. That being said, I would love it if we solved your problem, but we're not going to be able to change our computation model.
Right.
Our next question comes from Artur Marecki, and he asked, is there a way to use, or can PySpark be used with GPU, for example, used with CUDA easily? And if the answer is yes, could you recommend a good source of information, or how to learn about it?
It can be used with CUDA. Easily is another matter. Give me like a minute.
We can post some examples or resources in the show notes too if needed. So
yeah, I mean, there's probably like the easiest way to use PySpark with CUDA easily is by using Python libraries that are CUDA accelerated, and that's kind of a hack. There's some other tricky considerations when it comes to scheduling of CUDA accelerated jobs, and that can be really rough because Yarn, which is probably the most popular cluster manager for Spark to be deployed on, doesn't have a great idea of how to schedule around things like CUDA. And so for now, I think getting that to work really well is more of a power user situation. So there's not going to be like an easy, or there is like an easy 1, 2, 3 guide, but it's going to be misleading because in practice, it's not going to work that well.
Yeah, good to know. Avhirup Chakraborty asks again, what do you think could be improved about the distributed tools today?
Well, I mean, that's really broad. I think there's a lot of things that we could do. The people that I work with the most have a lot of trouble debugging. And so I think the most common thing that I see in different distributed tools where we can improve is error messages and explaining the state of the cluster to people when things have gone wrong. I don't think anyone does a really good job of that right now. And Dask does a better job, but still has opportunities for improvement, right?
Sure, yeah.
Flink is in the same boat. All of the tools, really, I think that's the most universal improvement I can see.
Yeah, it's good to know. Well, at this point, we've run out of time for our Q&A section, so we're going to move on to our world-famous rant section, where we each get about 15 seconds to rant about whatever topic we want. Holden, it is your soapbox.
Okay, cool. Cut me off when I go over time. I love the tools that we build, but in all seriousness, if we keep going down the path we are just going to create the world faster but poorer. We are going to just reinforce all of our existing stereotypes, but hide them inside of black boxes that we call models. And this is just going to make the world really, really bad. If your team is not diverse, you are just overlooking so many things. I've been in meetings where no one thought about the implication of sharing certain pieces of information, except one person on the team was like, hey, I haven't had an experience with this. We need to circle back and think about this. And to be clear, this is not at my current employer, which has really good data practices, et cetera, et cetera. But if you're working on a team where you're working with data or you're training machine learning models, you need to look at your team and ask yourself, does this team represent the communities that I'm serving? And if not, you should try and fix this. And this is equally true for open source, right? Open source is used everywhere, and that's terrifying.
Here, here. I couldn't agree more. David?
Uh, a long-standing pet peeve of mine is when institutions or organizations have ineffective policies that are known to be ineffective. Maybe there's research or other things that demonstrate how they're not effective. I recently learned about the in-school suspension policy and how it's practiced at my son's high school, and I was disappointed to find that it's basically comprised of sitting in a room and staring at a wall for an entire day, and maybe doing homework if your teachers thought to send an assignment to you and in school suspension. If you happen to fall asleep, you get in school suspension again. Personally, I can't imagine sitting in a room staring at a wall and staying awake. So I don't know how it doesn't become an infinite loop. And I found there was actually a whole bunch of literature on how to do it correctly and do it better and make it effective and not punitive. Yeah, so that continues to be just a general frustration that often we know the better answer and we don't pursue it. And in this case, our kids definitely deserve better.
Thanks, David. For my rant today, I'm just going to say that I've been planting some seeds recently, trying to get them started, and all of my Brussels sprouts have come in, but none of my peppers, and I'm really disappointed in my peppers. That's all the time that we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you're interested in funding open source projects, including PySpark, you can find all of the project roadmaps at quansight.com/projects. Holden, where can people find you and PySpark?
You can follow me on Twitter. It's just at Holden Caro. PySpark is at Apache Spark on Twitter, but realistically, you probably just want to go to spark-project.org and check out our community resources that are there.
Excellent. Thanks, and join us again next episode when I owe you a discussion on the Jupyter ecosystem. Bye, everybody. Thanks for watching.